In this chapter, we're going to talk about clash detection. As you probably know, clash detection is one of the most important processes in BIM project. It helps you find any conflicts in your model and fix them before construction starts. One of the main advantages of using BIM is exactly this, clash detection, because when you create a 3D model for different disciplines and then check them together, you can identify all the issues and overlaps before execution. This saves a lot of time and money, which makes clash detection one of the key stages in BIM. In this chapter, we'll go through the entire clash detection process in our project so you can see exactly how it's done. Now, the first question is, when should we actually do clash detection? Usually, clash detection is done after all the 3D models for different disciplines are completed. For example, when the architectural model, the structural model, and the MEP model are all finished, we perform clash detection to find the conflicts. Then each team fixes the clashes that belongs to their own discipline. Of course, you can detect some clashes during modeling. When you link other discipline models into your own Revit file, you might notice some problems as you're working and you report those. That's also a kind of clash detection, you can call it. The clash detection we usually software like Navisworks usually happens when all the models are complete. But even when modeling in Revit, you can still notice and report some issues, and that's very helpful. So we don't always use Navisworks for clash detection. There are different software tools for clash detection as well, but the most common ones are Navisworks and Solibri. But we mostly use Navisworks for this process. The main point I want to make is that clash detection doesn't only happen at the end. While you're modeling in BIM, you'll often notice clashes and report them right away. That way they can be fixed immediately and you won't face unexpected problems later during the construction. This is actually one of the biggest advantages of BIM compared to traditional 2D CAD drawings. In 2D, you couldn't see the conflicts until construction started, but now with 3D models, you can easily identify and fix them much earlier. For example, here that I'm going to show you in the project, I'm going to zoom in that we're modeling in this architectural. We noticed that one of the beams was too low and didn't give us the required ceiling height. We hadn't noticed it when we modeled the structure, but once we linked it into the architectural model, it became clear. So we reported it to the client, they made the change, and we continued working. So that's why that we say in 3D modeling, you can see the problem and identify it way earlier and report it, so it won't be a problem in future. Now, keep in mind that you're not always responsible for all the disciplines in the project, especially for MEP. That's usually handled by a specialized team for architecture and structure. It depends. Sometimes you only manage one discipline and other teams handle the rest. In international projects, each discipline is often done by a different team. Sometimes they are even in a different country, so keep in mind that not every discipline is your responsibility. For architecture and structure, it depends. Sometimes you only manage one discipline and other teams handle the rest. In international projects, each discipline is often done by a different team, sometimes in a different country. They share files through platforms like Autodesk or ACC and stay connected that way. So when you're only responsible for one discipline and you find a clash during modeling, you report it to the team in charge of that discipline. Then they will fix it, send you the updated file, and you link it again to your model and continue your work. Later, when all the models are completed, you'll do a final clash detection in Navisworks. You assign each clash to the related team and they take care of it. That's the general process of clash detection. That's one important thing to know. The final clash detection that's usually done in software like Navisworks. That's mostly done for the client, not for the Beam team itself. The client uses that process to review the models and identify any remaining issues between disciplines so they can see where the design or modeling problems are. Some of those clashes might have been related to construction and they wouldn't be visible during the modeling process. And that's basically what clash detection is all about. In most of the projects we've worked on, where our team was responsible for the beam process, the clash detection part was also one of our main responsibilities. So in the project we've completed after finishing the model phase, we were also in charge of running the clash detection and preparing all the clash detection reports. After we finished the project, the responsibility for clash detection and reporting was assigned to us, and we took care of that process. We prepared the reports and delivered them to the client. For issues that were related to other disciplines, we assigned those clashes to the relevant teams, and they made the necessary corrections in their models, and they sent the updated version back to the client. That's basically the full concept of clash detection that I mentioned earlier. Now, if you agree, let's move on and see how we actually perform clash detection. Because during the modeling phase itself, there isn't really a specific clash detection process. When you're modeling, you naturally come across some clashes and overlaps, and that's completely normal and expected. But now we're going to look at the stage where all the models are completed. And we want to bring them into another software to perform the final clash detection there. This is the point where we move from modeling to use a different program. The time when we actually start doing the clash detection. We really use Navisworks for clash detection. As you know, Navisworks is also one of Autodesk's software tools, so it works perfectly with Revit. And that's where we can perform our clash detection. First thing that we need to do before the clash detection is to export an NWC file from each Revit model. So the first step is to export an NWC file from every Revit model. Now, when I say every Revit model, what do I mean? In this project, that's what we've been working on together. Actually had several Revit files. One of them was for structure. If you remember, we modeled the waffle cells in this project. And a separated Revit file, we avoid making the main file too heavy. So basically the structure of this project was split into two Revit files. And as we saw earlier in the MEP section, the MEP models were also divided into separate files. If I show you here, you can see that we have two MEP files, one architectural file and two structural files. So when I say that you need to export an NWC file from each model, I mean you should export one from every single Revit file so that all of them can be imported into Navisworks for clash detection. That's the first and most important step of the process. So here I'm going to show you how. You need to open each one of your Revit files and export an NWC file from every single one. That means I open each file individually and export its NWC file one by one. That's our first step. Now, some people think they can just use the main Revit file and the one where all the other disciplines are linked and export from one single file, but that's not the correct way to do it. You need to export the NWC separately. Okay, so how do we actually export the NWC files? You probably know this already. We just go to the File tab, then go to Export. And here you'll see NWC Export. However, you might notice that this NWC Export option doesn't appear in your version of Revit. Why is that? Because starting from Revit 2022 and newer versions, the NWC Exporter isn't installed by default. When you install Revit, in the older versions, it used to work differently. If you installed Navisworks last, it would automatically install the necessary plugins. So what should we do now? The first thing you need to do is download the NWC exporter manually. How do you download it? It's really easy. Just go to the Autodesk website and search for Navisworks exporter for Revit. Now, there's one important thing to remember. You must download the exporter that matches your Revit version. So it's not one-time download for all versions. For example, if you're using Revit 2026, you need to download and install the 2026 exporter specifically. All right, let's do that. I have the 2026 version, so that's what I'm going to search for. Now, there's one important thing to remember. You must download the exporter that matches your Revit version. So be careful with that because every exporter is gonna need the same Revit version that you are using right now. Because I'm using the 2026 Revit version, I'm just gonna search for that. And usually when you search for it, you have to go to the Autodesk's official website. Now let's go and search for that. Okay, we're gonna click the first link, and that's the Autodesk's official website. It will guide you through everything. It's very simple. Here, I'll open the page. Okay, so here I'll open this page, and as you can see on this page, there is a free version that is listed that's not useful for us. So we're gonna select the other one. Scroll down to the proper section, select it, click to download. So once you click the link that is accurate to your Revit file, it will start to download it automatically. You don't have to do anything else. Here, I'll click the 2026 version, and as you can see, it's gonna start to download. And once the download is finished, you can install it. Just make sure to close Revit before installing it. You're gonna find the file and you're gonna double click on it and it's gonna download it. So keep in mind before exporting your NWC files, you must have the NWC exporter installed first. So if you click here and you don't see the option for inside of the Revit for the exporter, then install it before you continue.